In early March 2026, the Persian Gulf became a testing ground for a new model of air warfare. Following the coordinated U.S.-Israeli strikes of Operation Epic Fury, a massive retaliatory drone campaign completely flooded the regional airspace. Defensive networks recorded 1,668 distinct strikes during the first week alone, marking an unprecedented level of aerial saturation in the region. These operations established that one-way attack drones now function as the primary strike asset in modern air campaigns, rather than as secondary harassment tools. In this model, the immediate objective of a mass drone wave is rarely the total physical destruction of a specific high-value military installation. Instead, the goal is asymmetric cost imposition. By launching hundreds of low-cost systems, the attacker forces a defender to expend finite, multi-million-dollar interceptors, fracturing the economic and operational sustainability of regional security. Countering this threat requires shifting focus away from legacy air defense and reverse engineering the adversary's operational doctrine from the strike data itself. This strike distribution data confirms the campaign was tailored to specific targets. The UAE absorbed 1,422 detected drones, 2/3 of the total volume, due to its commercial hubs. Simultaneously, high volumes in Bahrain and Kuwait reflected their proximity and role hosting U.S. military posture. This chart shows a functional division in weapon assignment. Strikes against the UAE and Saudi Arabia were drone-heavy, accounting for 85% of attacks. In Qatar, the ratio flipped, with missiles making up 68%. This suggests using drones for persistent pressure, reserving high-end missiles for military targets. This daily volume graph tracks the campaign's temporal logic. The operation opened with a massive wave of 1,206 strikes on March 1st alone. Following that initial surge, daily strikes stabilized between 190 and 392 for the remainder of the week. The data reveals a two-phase campaign, an initial shockwave intended to saturate and blind radar networks, followed by a sustainable attritional phase designed to bleed defender resources over time. This inventory of recovered wreckage confirms a reliance on the Shahed family. The piston-engine Shahed 136 served as the backbone, carrying a 50-kilogram warhead with a 2,500-kilometer range. To diversify attack profiles, they introduced the smaller Shahed 107 and the jet-powered Shahed 238. Mixing these systems allows an attacker to generate multi-speed waves, where drones traveling at different velocities arrive at the target area simultaneously. These multi-speed waves shorten warning times and complicate tracking algorithms, forcing air defense systems into increasingly compressed engagement cycles. Forensic analysis of wreckage in the UAE revealed a significant anomaly: the presence of the Garan-2, a Russian-produced variant of the Shahed 136. These units featured Russian modifications, including the Kometa-M jam-resistant navigation system. Their presence suggests that drone cooperation between Iran and Russia has evolved into a reciprocal exchange of technology. Adversaries are actively iterating hardware configurations to ensure a percentage of the swarm always penetrates legacy defense nets. This creates a mathematical paradox for traditional air defense. Defending a target with a $4 million Patriot missile against a $30,000 drone is a strategy for rapid economic exhaustion. High-end surface-to-air missiles are simply too scarce and too expensive to be the primary layer of defense against mass drone saturation. Beyond the cost, mass saturation degrades air situational awareness. Radar screens flooded with low-cost, low-altitude contacts create an environment where identifying hostile targets becomes nearly impossible. This friction is lethal. In Kuwait, dense aerial activity during the campaign led air defenses to misidentify and shoot down 3 U.S. F-15E aircraft. Even the most advanced interceptors are insufficient if the system architecture is easily blinded and bankrupted by low-cost mass. The primary lesson from the Gulf and Ukraine is that defending against mass requires mass on the defensive side. A modern defense must start with a baseline layer of cheap, mass-produced interceptor drones. At a cost of $2,000 to $4,000, these systems allow defenders to engage OWA threats at scale. Ukraine has demonstrated this model's viability, fielding up to 950 anti-Shahed interceptors per day. This preserves higher-end missiles for cruise and ballistic threats that drones cannot handle. Hardware alone is insufficient. This ecosystem requires advanced sensor fusion and battle management software. Because communications will be contested, these systems must operate using onboard AI. If the central command link is jammed, interceptors must autonomously form mesh networks to continue the defense. This architecture also demands specialized human capital, counter-drone units with dedicated training pipelines and tactics capable of adapting to rapid hardware iterations. Effective defense requires a living, heavily integrated ecosystem of cheap mass, intelligent software, and specialized doctrine. Operation Epic Fury has confirmed that the global barrier to entry for executing strategic air campaigns has permanently lowered. In this environment, military advantage is no longer tied strictly to the possession of a few technologically elite million-dollar interceptors. Superiority now belongs to the side that can most rapidly produce and iterate a resilient, low-cost defensive network. For the U.S. military and its allies, counter-UAS must be fully integrated into future procurement, doctrine, and operational planning to address the reality of mass drone warfare.